Bonding the neutral and ground in the meter socket is required by National Electrical Code Section 250.24 FIRF, even if it is not a current transformer meter socket. Do not bond the ground and neutral again in the main disconnect or panel. The bond in the meter socket is sufficient. According to National Electrical Code Section 250.66 B2, the largest grounding electrode conductor needed is number 6 copper or number 4 aluminum, regardless of the presence of building steel or a cold water pipe. Sizing the ground rod according to Table 250.66 is not necessary. However, if connecting to an existing ground rod with a conductor larger than number 6 copper or number 4 aluminum, the new conductor must match the size of the existing one. Grounding and bonding are crucial for electrical safety and ensuring proper operation of electrical systems. The grounding electrode conductor connects the grounding electrode system, such as ground rods, to the electrical system's grounded conductor, typically the neutral, and the equipment grounding conductors. This connection provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices like circuit breakers or fuses to operate and clear the fault. Bonding refers to the connection of non-current carrying metallic parts of an electrical system to create an electrically conductive path. This includes equipment enclosures, metal raceways, and other metallic components. Bonding ensures that these parts are at the same electrical potential, minimizing the risk of electric shock. The National Electrical Code provides comprehensive guidelines for grounding and bonding to protect people and property from electrical hazards. Section 250 covers the requirements for grounding and bonding, including the size and type of grounding electrode conductors, the methods for connecting to grounding electrodes, and the bonding of metallic parts. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes. The grounding electrode conductor connects the grounding electrode system to the electrical system. The size of the grounding electrode conductor is determined by the size of the service entrance conductors, as specified in Table 250.66 of the National Electrical Code. However, as mentioned before, Section 250.66 B2 states that the grounding electrode conductor never needs to be larger than number 6 copper or number 4 aluminum when connected to ground rods or ground plates. When connecting to an existing grounding electrode, such as a ground rod with a larger conductor, it's important to maintain the same size conductor to ensure proper continuity and performance of the grounding system. Bonding the neutral and ground at the service entrance, typically in the meter socket, establishes the reference point for the electrical system. This bond ensures that the neutral conductor is at or near ground potential, reducing the voltage between the neutral and ground. Bonding the neutral and ground at multiple locations can create circulating currents and other problems, so it is generally only done at the service entrance. Equipment grounding conductors provide a path for fault current to return to the source from equipment enclosures and other metallic parts. These conductors are typically connected to the grounding bus in the electrical panel and then to the grounding electrode system. Proper grounding and bonding are essential for electrical safety and ensuring the reliable operation of electrical systems. The National Electrical Code provides detailed requirements for grounding and bonding, which must be followed to comply with electrical codes and standards. It is essential to consult the latest edition of the National Electrical Code and follow the manufacturer's instructions for grounding and bonding equipment. Always consult with a qualified electrician for specific guidance on grounding and bonding requirements for a particular installation. Grounding electrode conductors play a vital role in electrical safety by providing a path for fault currents to flow back to the source, allowing overcurrent protection devices to operate and clear the fault. They also help to stabilize the voltage to ground during normal operation, reducing the risk of electrical shock. The selection of the appropriate grounding electrode conductor size is crucial for ensuring the effectiveness of the grounding system. The National Electrical Code provides guidelines for sizing grounding electrode conductors based on the size of the service entrance conductors. However, it also specifies that the grounding electrode conductor does not need to be larger than number 6 copper or number 4 aluminum when connected to ground rods or ground plates. Ground rods are a common type of grounding electrode, typically made of copper or copper-clad steel. They are driven into the ground to provide a connection to earth. The number and spacing of ground rods are determined by the soil resistivity and the requirements of the National Electrical Code. Ground plates are another type of grounding electrode, typically made of copper or steel. They are buried in the ground to provide a connection to earth. Ground plates are often used in areas with high soil resistivity or where ground rods cannot be easily installed. Metal underground water pipes can also be used as grounding electrodes, provided they meet certain requirements of the National Electrical Code. The water pipe must be in direct contact with the earth for at least 10 feet, and it must be electrically continuous. Building steel can also be used as a grounding electrode, provided it is effectively grounded and meets the requirements of the National Electrical Code. The building steel must be electrically continuous and connected to the earth through a grounding electrode system. The connection of the grounding electrode conductor to the grounding electrode must be made using approved methods such as exothermic welding, listed connectors, or other means specified in the National Electrical Code. The connection must be mechanically strong and electrically conductive to ensure reliable connection. Bonding jumpers are used to connect metallic parts of an electrical system to ensure that they are at the same electrical potential. This includes bonding metal water pipes, gas pipes, and other metallic components that could become energized. Bonding jumpers must be sized according to the requirements of the National Electrical Code. Equipment grounding conductors are used to connect the non-current carrying metallic parts of equipment to the grounding system. This includes equipment enclosures, metal raceways, and other metallic components. Equipment grounding conductors provide a path for fault current to return to the source, allowing overcurrent protection devices to operate and clear the fault. The size of the equipment grounding conductor is determined by the size of the overcurrent protection device protecting the circuit. Ground fault circuit interrupters are used to protect people from electric shock. They detect small amounts of current leakage to ground and quickly de-energize the circuit. Ground fault circuit interrupters are required in many locations such as bathrooms, kitchens, and outdoor areas. Surge protective devices are used to protect electrical equipment from voltage surges caused by lightning or other events. They divert the surge current to ground, preventing it from damaging sensitive electronic components. Proper grounding and bonding are essential for electrical safety and ensuring the reliable operation of electrical systems. It is important to consult the National Electrical Code and follow the manufacturer's instructions for grounding and bonding equipment. Always consult with a qualified electrician for specific guidance on grounding and bonding requirements for a particular installation. Ignoring grounding and bonding requirements can lead to electrical shock, fire hazards, and equipment damage. By following the guidelines of the National Electrical Code and using proper grounding and bonding techniques, it is possible to create a safe and reliable electrical system. Remember that electricity can be dangerous, and it is essential to take all necessary precautions when working with electrical systems. Always disconnect power before working on electrical equipment, and use appropriate personal protective equipment such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Grounding and bonding are complex topics, and it is important to have a thorough understanding of the requirements of the National Electrical Code. By following the code and using proper techniques, it is possible to create a safe and reliable electrical system that will protect people and property from electrical hazards.